right, so in the packet, I'm so excited. The new packets came in. They're looking beautiful. They're coming soon. All right, we're on lesson 31. We're on page 34. And I need to regroup you all. I need to regroup you based on your physics experience. Where are my friends that have taken or are taking AP Physics? Holy Toledo! So many. So, nobody back there? AP Physics? AP Physics. Okay. Michelle, can you go join the men over there? And Sheila and Geraldo, can you guys switch places? Excellent. Oh my God. So many people in AP Physics. This is going to be a piece of cake. And if it doesn't go well, I know who to go blame. Mr. Tarek. Okay, you will need your graphing calculator. You're going to need an open mind on whatever page looks like this one. Page 34. Okay. So far, all the conversations we've had in this unit have been about big F, little f, f prime, f double prime. They're all functions and their derivatives. Diego, new stuff coming your way. Mind-blowing stuff, new calculator skills for you, Henry. Paul, would you be willing to drive that computer? All right. So what I want you to do, take a minute. Take a minute. Read the introduction at the top of page 34. And then get me a sketch of this function. Now, I want a good sketch, clearly labeled units, all the things. My goodness, it's cold in here today. I wish I had a horse blanket on me. I'm going to go cuddle up a piece of
What if you go to work?
There you go. Alright, Jose, Victoria, and Nathan need to attend a fundraising event for Maverick Nation. Rather than taking their own cars, they've decided to borrow Mr. DeRoche's vehicle for the afternoon. Don't ever do this. Their velocities they travel along I-10 can be modeled by the function v of t equals 10 e to the square root of t times sine of t on the interval 0 to 7. Now, we've run into this problem before. If I give you an interval, if I give you a domain restriction, that's the only thing I want to see on your calculator. Don't tell me about things outside of that interval. I'm not interested. Also, Paul, that's not the graph. Anybody see the mistake?
He put sine of an exponent.
You want? I don't want sine of x in the exponent. I want sine of x down next to the e to the square root of x. Okay? Get yourself a good window so everything is visible. This up. There you go. Sine. Okay, that's looking pretty good. We've got the domain restriction in place. I just want to make sure I can see the whole graph. I want to see the highest high points and the lowest low points. Get them both. Okay, Daisy's got a good looking graph. Nice curves, Daisy. I can probably go to prison for that, yeah? Okay. You tell me. Anybody have a good Y-man for Paul?
Negative 100, 100.
Negative 100 to 100.
Negative
No, that's still too
I want to make sure that we can see the high highs and the low lows.
Y is negative 100 and Y max like 120.
Okay, negative 100 and positive 120, what Chris says. Negative 100, positive 120. Hopefully everybody's got a graph that looks something like this. Everybody good? Okay, so I want to label it. What are we measuring on the x-axis?
Time.
Time, what are the units?
Seconds. Hours.
Careful, hours. And on the y-axis, what are we measuring?
Miles per hour.
We're measuring miles per hour. Well, those are the units. Those are the units. We're measuring velocity in miles per hour. And Karina, if I'm over here, can people see? Okay, part A, we've got a graph. Good. B, on what interval is the velocity of the car increasing? This should be a really easy question for everybody in the house. What are we going to do? When's the velocity increasing? You should be able to see it. Right, this is the graph of the velocity. So Sylvia, where are we increasing? You don't have to tell me exactly, but like from right here where we start until
There.
over here, which we know is the max. Where else are we increasing?
From the min
From the min
to the
up
min.
until the end. So you're going to analyze the graph. So v of t increasing, I think we can all with confidence say from 0 until, did we get the max? Okay, Paul, I want you to fix the settings. Can you hit menu? And then option 9 for settings. And then, oh, float. No, we don't float here. Fix 3 or higher. I got a new computer last week and I think, there you go, that's the issue. Okay, so from 0 to 1.917, are we increasing at that max or not? This is going to be one of those places where the College Board's going to be forgiving. You might put parentheses, you might put brackets. Either one is fine with me. They will accept both here. And then we're also increasing, what is that, 4.933? 4.933 over to 7. Everybody should be okay. We haven't done any calculus yet. We're just getting the lay of the land. Sketching it would be good. All right, part C. Evaluate v of 2 and dv dt at t equals 2. Using correct units, explain the meaning of each answer in the context of this situation. This is where I'm going to shut up and let you do what you can do with your calculator. I want the number, I want the units, and I want an explanation of what that means. I wonder if you're not in, that's why you only have one way rating. There you go. Okay. Paul, can you show us how we're going to get v of 2? So menu, trace, graph trace, and then just type in 2. And according to Paul's calculation, v of 2 is 37.4017. Hopefully everybody's okay. dv dt at t equals 2. You guys know what to call this. dv dt? This is the derivative. This is the derivative of the velocity with respect to time at t equals 2. And you're just going to use the calculator. You're just going to use the graphing calculator to go find that derivative. Okay, somebody tell Paul, what are the steps? What are the steps for finding the derivative on the calculator? Oh, okay. Some of you, I think, are wanting to. if you're saying like hit tab, you're going to create a new function, and you go to like the little catalog button, that would get you the graph of the derivative. Right now, all I need the derivative at t equals 2. I need it at one little point. There's another way to do this on the calculator. Jose, do you remember?
Control T.
Control T is going to build a table. I just want to find the derivative at one point. So Paul, menu, analyze graph. dy dx. It's right. It's been a while. If you just need the derivative at one little point, menu, analyze graph, dy dx is going to get you there. And according to Paul's calculations, just type in 2, and you can grab it and move it if you want to. Negative 3.8937. This first one says at time t equals 2, the velocity is 37.4017 miles per hour. Right, not calculus, just like algebra 2 pre-calculus stuff. I'm really interested to see what you guys can do with this next one in terms of the explanation. It's been a while since you've done it. We'll check in a minute. What's the full sentence explanation, including the units? Sheila.
For what? For the negative 3. Isn't it? At time t equals 2.
The average?
There's no average, right?
No,
No, but there's no average.
no, but the rate changes.
Huh?
The rate changes. Or the rate increases.
It decreases. So
Oh, I haven't seen a good explanation yet.
at time,
I've checked in with a whole lot of folks, haven't seen it yet.
at time
So close.
t equals 2.
Close over there.
The rate of the velocity.
Close, but didn't cut it. Okay, I have not seen a fully correct explanation. Why do I keep coming over to Destiny? She's taking the test. Okay, pretty common. At t equals 2, the derivative is a rate of change. Not an average rate of change, an instantaneous rate of change. At time t equals 2, what's the rate? What's the velocity doing? The velocity is decreasing at a rate of, and here's where mistakes happen, 3.8937 miles per hour. I didn't see the correct units on any single paper anywhere in this room. One person, maybe 2 people. The key with the units is you look back over here. How are we measuring velocity?
Miles per hour.
Miles per hour. How are we measuring time? Hours. So it's miles per hour. Per hour, or even better, miles per hour squared. Yes, ma'am.
Oh, I was gonna say acceleration.
Miles per hour squared.
Acceleration.
And miles per hour squared, miles per hour, miles per hour squared. You know from physics, what do we know from physics?
Acceleration.
This is acceleration. So guess what, friends? Next time I ask you to find the derivative of velocity, what am I really asking you to find?
Acceleration.
The acceleration. Acceleration is the derivative of velocity. The units are the guide here. Okay, so with that said, let's push your thinking a little bit more. I want to know what the acceleration is, the time when the particle comes to rest for the second time. When that particle comes to rest for the second time, what's the acceleration? First of all, we've got to agree on what time are we talking about.
Yeah.
This one?
Yeah.
That one?
Yes.
How many guys are going for this one? How many guys are going for this one? How many guys have no idea? Be honest. Thank you for the honesty. Go back and read the question, Jeff. One more time. What are we looking for?
The acceleration of the car the second time it comes to rest.
The acceleration of the car the second time it comes to rest. So I would argue at this time, you're already at rest. You haven't come to rest, you are at rest. So this time over here, the first root is when you have come to rest for the first time. And this is when you've come to rest for the second time. This is the one that I would go for. I don't know that the College Board would ever word it that way because they like to avoid language issues. So did we figure out what that time is? 6.28. 6.28. I need one more decimal place. 6.283. So I want, or I need, the acceleration at t equals 6.283. Well, what are we going to do? How are we going to get the acceleration at 6.283? Acceleration is the derivative of the velocity. So all I'm asking for, Diego, is what's the derivative at this particular point? So go get it for me.
What is the 122? What's the 122?
What's the 122? That could be the
It's
okay, and you gotta change your settings. 122.626?
Yes.
Okay. So maybe we want to write this as dv dt at t equals 6.283 is 122.626. And again, I want units. I always want units. Miles per hour squared or miles per hour. Either way works for me. Is everybody okay? I need you to know that acceleration is the derivative of the velocity. And now it's time for the next push. Keep going. See what you can do with this next part. Jack, you okay?
I'm not understanding like how far the year talking about
The approximate. Okay, because in the last question I was asking you
It's from 1.91 whatever to 0 because velocity right there is positive, but acceleration is
analyze
negative.
graph.
It's at 4.9.
Acceleration is positive.
And then type in 6.289.
No, velocity would be negative. So it'd be the point that you said, that one,
Yeah, then it's actually the acceleration.
no,
Okay.
this.
First of all, let's change your settings. I want to see fix 3 or higher. Here, menu, analyze graph, fix 3. Get 122. Perfect. All right. So part E, on what graph will the velocity be negative? I need velocity negative and A of t acceleration positive. How am I ever going to know from the graph? Karina, you're frozen for a little bit. Velocity negative, I hope that's the easy part. Acceleration positive. acceleration is the derivative of velocity. So if acceleration is the derivative of velocity, and the acceleration is positive, what has to be true about velocity?
Velocity has to be.
Not above the x-axis. Acceleration, if I had an acceleration graph, the acceleration would be above the x-axis. But acceleration is positive, and you guys told me that acceleration is the derivative of velocity. So if instead of f prime, f double prime, we're thinking about velocity and acceleration, acceleration's positive. What's the velocity doing? Increasing. So all I need to know is when is the velocity increasing and at the same time negative. Go get that interval. You've got to make that connection between acceleration and velocity for this to work.
Oh. So I said 0.449338 is below. So that's when you know it's negative. And then since you know it's going up with one acceleration and stuff.
So velocity is negative and increasing. We should be looking at that part of the graph. Adrian, do you have what this value is?
Which one?
The lowest point? 4.933, and then the root 6.283. Okay, so if all goes well, you get the interval 4.933, 6.283?
Yes, sir.
Okay, you just need to keep in mind acceleration's derivative of the velocity. So all those derivative relationships we've talked about should work. So let's keep exploring this idea that acceleration is derivative of the velocity. These next two, parts F and part G, are asking you to sketch the acceleration function. I want you to sketch the acceleration given the velocity. I'm not going to tell you how to do it. You already know how to do this. Don't use your calculator. Just use your brain. Your very excellent brain. What do you know that has to be true about acceleration because you see the velocity graph? The whole velocity what? Yep. Well, in part E, the question was, when is the velocity negative and the acceleration is positive? Acceleration is the derivative of velocity, so if acceleration is positive, then velocity must be increasing. So I'm looking for where these two things are happening on my graph, velocity negative and velocity increasing. Eva?
Can you see the acceleration graph like
This would be a point of inflection?
the first derivative? And then like,
Yes, because acceleration is the derivative of velocity.
so when I took,
Yeah.
I mean,
Yep.
year to year, I got like
Wouldn't this make it a coast?
Wait, it looks like
Wouldn't it make it a coast? Yeah, right? But that's what I remember. I remember like, when we did the graph last time, when we said the sign changes the coast, the
yes,
coast changes
I
the
also
sign.
need not just acceleration
So that means
below
it'll
the
start
x-axis,
on
above the
Yeah, it
x-axis,
will start
but you also
on
need
top
somewhere
of
velocity
here.
would increase.
And
And you're not going to see your acceleration graph.
But it would still start at 0.
No, but then it's like, you remember when I told you that
Alrighty,
the
friends.
size, the coast, and the river,
Let's do it. I want a sketch of the acceleration graph. Some people have done a pretty decent job with that. Two important things you need to know. Number one, you're looking at the velocity graph. Number two, acceleration is the derivative of the velocity. So if I ask you to sketch the acceleration graph, I need things that you know from the velocity graph and what it tells you about acceleration. I'll take anything from anybody. Jeanette, something that you know.
When f of x is,
Not f of x.
v
of t.
is above the x-axis.
Yeah.
F prime, v prime of t is going to be greater than 0.
I just heard you say v of t above the x-axis.
Or increasing.
That's what I wanted to hear. If v is increasing, then v prime, which is acceleration, has to be positive. So when the blue graph increases, the red graph is positive. Okay? But a better place to start. A really good, safe place to start. We always start the same way. Gonzalo, where do we start?
You already know the maximum velocity of that element.
Bless you.
Yeah.
The minimum, the relative minimum of the vegetable.
Okay, so I hear you focusing in on these two places, right?
Yeah.
What's so special about those two places?
They are zeros in the f and the acceleration. They stay like the acceleration equals 0.
The acceleration is equal to 0, but I want to hear a calculus reason why the acceleration is 0. Did you listen? You have a horizontal tangent line here. That may not be the language you are using in AP Physics, but we know that if my graph has a horizontal tangent line, then my derivative has to have a
0.
a root. So these are going to be my roots. Now you can make comments like, oh, well, I know the blue graph is increasing. So what's the derivative doing? It's going to be above the x-axis, so maybe I draw it like that. That's good enough. Karina?
I was gonna say, since you drew it like that, wouldn't it be a cos instead of a sine?
You've got some good ideas there that I want to loop back around to in about 3 weeks. Because you don't know about the product rule yet. Is everybody okay? Blue graph increasing, red graph positive?
Yes.
Okay, what else? We've got blue graph is decreasing. So it has to be true that the red graph is going to be negative.
Yeah.
But I'm going to be negative going from a root to a root. So I'm just going to sketch something like that. I'm not going to worry about sketching too much more. And then after this, my blue graph is increasing. My red graph is positive. That's my sketch. It's good enough. And if you want to compare your sketch to the real acceleration graph, we know how to do that too. This is what you guys were trying to tell me to do earlier. How do you figure out what the acceleration graph looks like, Sylvia?
Put in the second one for an f of 2,
Okay, f of 2, so let's arrow up here. So you would have done tab.
and then you press the little Bible.
Not the Bible, the one next to the Bible.
Yeah. And then you put that one, the d of x.
The D box.
Then you put x,
X.
and then f1.
Not F1, F1 of X. You need the X in there to make this work. And lo and behold, if all goes well,
Wow.
the new graph, not perfect. It's not, our sketch isn't perfect.
It's almost perfect.
It's almost perfect. But this is what I'm looking for in your sketches. Do you have roots where you're supposed to have roots?
Yes.
Are you above the x-axis where you're supposed to be above the x-axis? And are you below the x-axis where you're supposed to be below the x-axis? That's good enough,
Yes.
Karina.
So in the middle of the velocity graph,
Yeah.
you know, like when it's like
When the velocity graph?
yeah, like from the right there from. Can I show you?
Get aggressive, Karina.
Right here, and then you switch it, and then it's be like other related.
Is what related? Me and you? No.
No.
We're not related.
The minimum to this.
The minimum for the velocity is related to something special on the velocity.
Point of?
It's the point of inflection. It's the point of inflection. All the friends are okay? Okay. Karina was focusing on the fact that the acceleration graph has a minimum. But the acceleration is the derivative of velocity. If the derivative has a minimum, then this function has a point of inflection. Because your derivative changed from decreasing to increasing, that means that the original function changed from concave down to concave up. Henry, I see you, but we're going to move on. We're going to move on. All right, next sketch. Next sketch, I want the speed function. Speed function. Get me that speed function. All the AP Physics people at the table, you know there's a connection between speed and velocity. Help out. Speed is not the antiderivative of velocity.
You say answer. Remember that speed is always positive.
Paul, if you could get rid of the acceleration function.
When this is when this goes negative, this will be positive. This will be positive.
Oh my gosh, Mr. T is upset right now and he doesn't even know why. He can feel the bad physics happening across the campus. There is a connection between speed and velocity that no one has brought up yet. There's a connection. Rebecca?
Oh,
Speed is the...
No! You can't do that!
Yes, she can. She's a DeRozier. I also have been walking around for the last 30 seconds like this saying there's a connection between speed and velocity. Hoping that this was going to make you think.
The blue pill, the red pill.
Yes, the matrix. The absolute value bars. Dummy. Okay. So, go give me the speed graph. Get me that speed graph.
Isn't it just like a quadratic function?
It's not quadratic. Some of us are making some assumptions.
It's just like I told you, it's positive.
Nice.
Instead of going negative, it stays positive.
Speed is the absolute value of velocity.
Yeah.
Your sketch
That's one. So it's
Directed?
ought to look
that's when it's
something
positive.
like that.
Oh wow.
Way back in pre-calculus, she talked about absolute values being a transformation of a function. In pre-calculus, if you took the absolute value of a function, places where the function is above the x-axis stay above the x-axis. Places where the graph is below the x-axis, what happens there? It's a reflection up above the x-axis. So that's the graph. Okay, so show me what you can do with this. Where is the speed graph increasing? I want intervals where speed is increasing.
Zero to. But isn't it?
Where's the speed increasing? I want intervals. I want start points and end points.
Isn't it always increasing?
oh, okay.
It's just like when it goes down, it's the lower.
Okay, therefore, we figure it out.
It just means that you did the corrections, and when you take the test, if the test grade is higher, the quiz grade is lower.
Point to
Yeah.
point. Point.
Okay.
Point. Go ahead and break that right now.
All right, friends, places where the speed is increasing. Starting right over here, t equals 0. Going until
The max.
the maximum.
Yes.
Another place is the root. Up until the maximum again. Hold on, Karina. So we're going to say from 0 until, did we ever find out the coordinates for the max?
1.917.
Is that right, 1.917?
Yes.
From 0 to 1.917, parentheses or brackets, we can be kind here. And then the next root is at 3.1416. 3.1416 to the new max. And if you're like, but wait, I don't have the speed graph on my calculator, how am I going to find this max?
It's the opposite of the minimum.
It's not that it's the opposite of the min.
The positive.
If I know where the minimum is on the velocity graph, That is the maximum on the speed graph. So where's that minimum? 4.933? 4.9338. I needed like 3 more minutes. We didn't get exactly where I wanted to, but you guys should be fine. The homework this weekend, assignment number 31, has everything to do with physics, but here's where you need to be careful. There are questions that are going to ask you about things like the intermediate value theorem, explaining instantaneous rate of change. You're going to have to demonstrate continuity and differentiability. This is meant to be a review to get you ready for the unit test next week. See you guys later. What's up, Paul?